Guys, just wanted to make a short video just to help you out and explain for the people that might miss the in-class explanation for how to go about doing these, your second tier of activities. You should have already completed the dynamic earth. Now we're going onto our tactile kind of hands-on. Remember, you're going to pick two of these. And please do not forget, whichever activities you choose, what we're really after. Remember our quote-unquote crazy man, whose claim is that the Earth's crust, even though we can't really see it necessarily, the Earth's crust is cracked and broken into pieces, and he claims the pieces are actually moving around. So people are pretty skeptical, and he's left it to us, to kind of really research that question. Is that true? Is the Earth's crust broken into plates? And if it really is, if they're moving, he's looking to us for what's the evidence here? So we've already started to look at that with the dynamic Earth. Now, I wanted to quickly go through and show you two things, what each of these activities are very quickly, and then how you're going to go about on Friday in a couple of classes, how you're going to go about submitting these. So your first choice, if you choose this, is something called fossil puzzle pieces. And it's really what it sounds like. You're going to use fossils here that are literally on puzzle pieces to kind of match them together as evidence, which we saw if you did the dynamic Earth, that the continents and land masses, the crust, are moving, and that they used to actually be joined millions and millions of years ago together in different shapes. So direction sheet is here on this link. I'm going to go ahead and click this. And just to quickly show you, really all the puzzle pieces are, what you're going to get, rather, is, as we said, puzzle pieces. And on each puzzle piece will be, it's going to show you color-coded where fossils are. So they're kind of color-coded to help you match them up. And you're going to receive these puzzle pieces either in person or digitally. And you're going to try to logically piece them together so they form a giant supercontinent. So when you're satisfied with the fit, you're going to think about that and discuss that. So for these, what you're going to see, it just gives you a description of what these fossils are. Some of them are animals, some of them are plants. It talks about where and when and how they lived. So if we go back to our activity, I'll either have these puzzle pieces literally cut out on little cardboard pieces that you can manipulate if you're in person, or you can choose to use the puzzle pieces digitally as well. I just want to show you kind of what they look like quickly. And just as we said, all that you are going to be required to do, very, very simply, is you're going to use this workspace. Here are your puzzle pieces. And you're going to move them around and try to match up. You can see the land, the continental crust, and the color-coded, they're going to show you this is a range where they found these fossils. This is a range where they found these plant fossils. And what we want to try to do, I'll show you real simply with this small piece, is to move the pieces and match them up so that the land, you can see the land actually sort of fits together, and we can create a continuous swath of these fossils. So these fossils sort of match up. Now you might choose to do it like that. You might find another piece over here. Now obviously these pieces don't match up because the shapes don't match up and the fossils don't match up. I might choose to try something a little bit differently, like, oh, maybe this goes over here. I can kind of see where they fit together, and my fossils align as well. So you're going to mess around with those and try to recreate the supercontinent. Now, when you're done with that, you're going to take a picture of that, either on your Chromebook or a screenshot of this. And then all you're going to be asked to do is on Friday, you're going to have the opportunity to turn that in. So if you choose the fossil puzzle pieces, there's just going to be this little blank Google Slides template. And just like we've done before in the past, all I'm going to ask you to do is to attach your picture of the completed puzzle pieces, either a picture with your Chromebook or a screenshot. And then there are just going to be a few, you're going to attach that right here, as it says. And then there are some reflection questions I'm just going to ask you to answer. You're going to type your answers right in the slides below. So that's it. Pretty simple, if you choose to do that one. So remember this, if you choose to do the fossil puzzle pieces, we're thinking about how is this actually evidence to support that crazy guy's theory? Does this provide evidence to say, yeah, you know what, maybe the crust in the is broken into plates and they are moving and have been moving? Or does this blow holes in that theory? Is that not true? So there's your first option for that. Now, your another option you might have is this foam block hands-on modeling. Now, all this is, you're going to open a PDF with Cami, pretty simple and easy, and you're literally, just like it sounds, you're going to manipulate blocks instead of puzzle pieces to simulate what would happen if or when plates move when they come in contact, when they move away from each other, or when they collide with one another. In trying to do that. So just want to show you really quickly what you are going to have when you do that. Pretty rudimentary, pretty simple. You're going to have blocks. They're foam blocks. You can see the blue, they have arrows on them. The thicker, the blue is thicker, you can see that represents continental crust. The crust that's exposed on continents. And they use the foam because continental crust is thicker. The cardboard, much, much thinner than the continental crust, you can see. That's meant to represent oceanic crust. So what you're going to do is you're going to simulate and manipulate these hands-on to actually show, we'll go ahead and get rid of our thing here, to actually go ahead and show via the directions what these plates are doing. So in our initial research, these are the names for the types of boundaries. Like divergent is where plates move away from each other. We can kind of see arrows right here, for example, showing like, hey, oh, these arrows, this plate's moving that way, this plate's moving that way. They're moving away from each other. There's a boundary. Convergent is where they move towards each other. So we could see like the two arrows, for example, right here on this lower down, this Nazca plate is moving into the South American plate. They're colliding. So this gives you a little refresher and a reminder. And all you're going to do is you're going to complete these models, really. So for example, you're going to take two foam pieces with the arrows shown, and you're literally just going to move them with your hands like the arrows tell you to do. Slowly follow these directions. And then all you're going to do is use the tools here in the space below to draw just what did you notice happening, if anything, and then a really brief explanation, a response to these questions. You're going to use a text box here, and you're just going to go ahead and type your response down here. So for each of the scenarios, you're going to model, we've done modeling before, what happens when continental plates move past each other, what happens when oceanic plates move past each other, what happens when, again, following directions, oceanic and continental crusts slide past each other, what happens when they mid-continents collide together. So there's a lot of different explanations here in what we're doing. In fact, there is a small error on this guy. The arrows are not shown to you. You're actually, what you're going to do here in this one is you're going to move the arrows, the plates are going to collide together this way. So there's a little mistake here on this one, on Model C. There is a small error. So instead of doing them this way, you're going to push the plates together. So those arrows, there's a little bit of a mistake there. Instead, you're going to push the cardboard oceanic into the continental crust that way. And you're going to observe what happens, draw it below, and respond to those questions. So that one, in and of itself, is pretty simple. And again, if you choose to do that, you're just going to, you either have the document here on Friday, or you're going to have your own Cami document, and you're just going to attach it to this assignment on Friday and submit it. And I'll be able to see your drawings and see your responses to the questions. Simple, simple. Now, again, I'm going to go ahead and turn this off. We don't need this. The last one is a gizmo. And we've done a gizmo before. It's got the little code here. And all you're going to do, this is an electronic manipulation. It's a different version of this. So if you're a DL, you cannot do the foam blocks, but this will serve the same purpose. So there's a little Google Doc where that's going to guide you through. I'm going to show you what that Google Doc looks like here. It's a little copy of this document, so you can access that document here. And it's just going to guide you through with directions. You're going to type in responses as you go along, a little warm up here, etc. And now when you go to the gizmo, all you're really going to do, I can show you pretty quickly here, is you're going to be submitting that Google Doc when you're done. It's going to have all of your answers. But I want to show you really quickly what this will sort of what will look like. So instead of using actual blocks, you're going to have the ability to follow some arrows here to move. You can see I'm in a trial. I have not signed up, but you can click on it. It'll show you the type of the boundary names. It'll show you what's happening with the crust and the mantle we can see underneath. It'll show you also where in the world this happens. So you can change your boundaries up here. And let's take a look at this one. For example, boundary B, we are going to be right here. So it shows you a bird's eye view and it shows you a side view. Now, all you're going to do, it's going to tell you to take one of the plates and move the arrows. So if I click on that arrow, what I'm going to do is that plate is going to move this way to the left. I click it again, it moves more. I click it again, it moves more. I click it again, it moves. And all you're going to do is you're going to see this is a convergent boundary, a collision boundary. The plates are colliding together. You're going to see, you can always reverse it and replay it. What happens when this plate is colliding with the rest of the continental plate? We're going to see something form here. You can see them collide. You should recognize that feature. And you're going to go through and follow the directions on the, as we said, the gizmo document here. And type in your answers as you go along. It's going to guide you. And you're just going to play around with these plates. Now, what happens when oceanic crust collides with continental crust? So that one's a little bit different. That's convergent. They're coming together. And something's going to happen called subduction here, we're going to see. And when we do that, it's going to tell us, hey, we're just going to move this oceanic crust, this stuff right here, over and crash it into continental. And something's going to happen. So again, if you choose to do that one, all you're going to do, you're going to attach your document on Friday, your completed copy of your document with your answers, with your pictures or your tools for what you see happening. Very, very simple. You're going to mark up the document there. And we just do that. This is what you're going to turn in. All right. So again, all we're after, you're going to pick 2 of these activities, really simple. And I think whichever 2 you pick, it's going to help you gather more information for some of the stuff we saw yesterday. What's going on with these plates? If they are moving, is there evidence with fossils? Can we see, even though it's happening slowly, is there evidence that they are actually colliding and pulling away from each other? We can see down here. So it's really good practice to emphasize what we saw here. And obviously you'll be submitting them, like we said, on Friday, either right in the Google Slides or attaching your PDF or attaching your Google Doc, and you'll get a bunch of points for it. So pretty simple. All right, so that's that. I'll be here for questions. Again, this is just to help you out if you're not sure, but I'll be around in class and in the meets to help you out. Time to go play and explore.